Nice to see you again. In this talk, I will show you the assessment workflow for read across and the substance category formation. My talk will cover 4 major points. First one, general aspects on non-testing approaches. The second is the guidance elements on the analog approach and the category formation workflow. And then I'll show you a practical example in reality, and then I'll show you the workflow in AMBIT. The first one, general aspects. So as you all know, under REACH, lots of information are required, but all the informations can be from experimental studies, but we can also use non-testing approaches as described in REACH Regulation Article 13. Information on the properties of substances may be generated by means of other than tests. And also described that information will be generated whenever possible by other than animal tests, for example, so-called alternative methods. And it's also nominated that grouping or read across are very useful methods as non-testing approaches. And in addition, in Article 25, it's described that in order to avoid animal testing, the testing on vertebrate animals for the purpose of this REACH regulation shall be undertaken only as a last resort. So actually, ECHA encourage us to use non-animal testing approaches. This figure I already showed you. So the non-animal testing are widely used under REACH registration, especially the read across. And also for some endpoints, the QSAR predictions are also used. But for most of the endpoints like toxicity or ecotoxicity, QSAR predictions are not used so often. I think the reason is many QSAR tools are under validation or other analysis, so the reliability is not so acceptable, or the acceptance of QSAR predictions not so well as read across. Then ECHA has already published many guidance on the QSARs and read across approaches. For example, here are the workflow charts from ECHA guidance, the 6-part QSARs and the grouping of chemicals. So it's described the flow charts of analog approach and category development. So it contains several steps. Looks very nice. So if we close look at the analog approach, it has generally 6 steps. Step 1, identify potential analogs, and then step 2, data gathering for the analogs. Step 3, evaluation if the data are sufficient, then to construct a data matrix. Then to assess the suitability of the read across and filling the data gaps, and finally document the read across. It looks very simple, but actually the workload for each steps is very high. So almost every step, especially the data matrix generation and the data gathering. In order to help the assessor to better finish the job, so AMBIT was further developed, and for each step I think AMBIT could do a little bit, especially for the step 4 to construct data matrix, and step 2, the data gathering for all the analogs and as well as the target structures. I think the step 6 actually AMBIT will help also a lot to create the report automatically to document all the valuable information under the procedure. a practical example in reality. So this is an example for reach registration in phase 2 from client. So we created a category for pigment Nef2 ES. So you can see this is a data matrix for only the toxicity part. Each column is a category member, and each row is an endpoint, like acute toxicity, skin sensitization. For example, here the pigment red XY. The name is confidential. So this is this one, and skin sensitization is here. So it has all the data. So for example, here this category member is not sensitizing. So altogether we have 16 category members and 70 endpoints. So altogether we have more than 250 fields to be filled for this category. So it means lots of work for us. It also takes lots of time. It's only for the toxicity part. Maybe we have to fill the chapters for environmental fate, ecotoxicology, and also physical chemical properties. So in general, the category and the reader course approach is not so easy as we expected or as we considered. So therefore, we are looking for further tools to support the approaches. Therefore, we considered AMBIT to support our work. Then in AMBIT, we have developed a workflow to support the process. It's called a workflow for reader cross and category formation. So we combined the analog approach and the category formation together, because basically the procedures are similar. So it contains 6 main steps, as I already said. So from the assessment identification, collect structure, collect data, to generate a data matrix, and then at the end to create the report. Then I go to step by step. So according to step 1, identify potential analogs from the ECHA guidance. We start with assessment identifier under the tab of assessment in AMBIT. So here in this step, assessment identifier, we define the title or the identification for the assessment. For example, here I would like to perform a category for the chemicals claims. Then I give a title for this assessment. I define the owner of this assessment and also purpose of this assessment, and also code and where the documents are located. Then I click start here, and then the system will automatically generate a assessment ID for this assessment. And then the definition is finally finished. Then we go to next step to collect structures. Here we can collect chemical structures for the target chemical, as well as for the analogs and category members. So here to search for the target chemical, we click the search button, and here we can search the target chemical by a CAS number. So normally if you have a target, you already know something about the chemical. So you normally have a CAS number or you have a chemical structure. Then we find the chemical by the identifier. So you can input the CAS number and click the search, and then you can find, for example, this CAS number. I find this chemical. It shows the chemical structure as well as other identifications. Then I classify this structure as a category member, as a CM here, or a T for target. So if you don't know the CAS number, you can also draw the chemical structure by yourself, and then generate AMBIT will automatically generate a smart code for the picture. And then you find your target chemical. Then based on the target chemical, you can go to the similarity search to find the structurally similar chemicals in the system. So I give a smart code, and then I define the criteria for the similarity. So the 0.9 is very similar, and then I would like to have only the structures with data. So I search again, then I have a list. From this list, it shows all the similar structures in the database. So here's the similarity from 1, where the same, and then followed by the other similar structures. Then based on the structure similarity as well as other informations like the metabolism of the structures, to see if these two have a common metabolite. So it could be analyzed by other tools, like I already said, the AMBIT2 system, and also QSA predictions. And then from this list, I choose which one I can use as an analog, and then I can give the reason why I choose this structure as an analog to our target chemical. Finally, we generate a list of structures. So here basically it is all the category members for the structures. Then the structure collection part is finished. So then we go to next step called endpoint used. Here, based on the chemical structures, we search in the system. For each structure, we search for a substance. My colleague already explained what's the difference between the chemical structure and the substance. Basically, chemical structure is a single chemical, but substances, like rich substances, it has a composition. It contains many chemical structures normally. For example, here, for this structure, this monoglyme, in the system I found 2 substances, and each substance contains this chemical structure as a constituent. Sometimes it also contains it as an impurity, but normally for the category approach, we only select the substances contains the structure as a constituent. Sometimes we also can have a look at the composition. What is the concentration of the constituent in the Euclid substances. So we only select the very specific substances which contains this as a constituent. So it means the properties could be comparable. And then we'll select the relevant substance for each chemical structure. And next step is to select the endpoints of interest. For example, if we would like to assess only the toxicology endpoints, then we go to here to select, to check each endpoints like acute toxicity, or we can also, together with other endpoints like ecotoxicity or the physical chemical data. Then we select, and we can also see on this side if there's any data available on these endpoints. Then we check all the interested endpoints. Then we go to next step, assessment details. And the first one is initial matrix. The AMBIT will automatically generate initial matrix very quickly for all the substances we selected. So for example, here we have substances diglyme, triglyme, and tetraglymes. Then for each Euclid substances, we have a composition here, and then we have the data collected for each endpoint and each category member. here in the initial matrix, I had to mention that this data is all the available data in the system. It's called initial matrix. Then we go to next step called working matrix. Here in this matrix, we can edit the data collected in the initial matrix. For example, we can delete the data which we think is not reliable, or due to other reasons we can delete it by clicking the minus button, or most frequently if there's a data gap, we can click the plus button to fill the data gap. So if you click the plus button, then a pop-up window will show. So in this small window, we can input the data for this field. For example, this data can be from QSAR predictions, or most frequently we can make a read across. For example, here according to this data, we can make a read across here and input the value for this category member. Then we do it for all the gaps, and finally all the data will be generated and displayed as a final matrix. So then here in this final matrix, we have all the data from available data, or from the QSAR predictions, or from read across. And then we go to the last step called report. AMBIT will automatically generate a report for this category. It can be also exported as a Word file, or it can be also shown online. So in this report, it contains several sections. The first one is assessment identifiers, the identification of the assessment we've already imported. And the section 2 is a list of the structures we selected. And section 3 is a list of the substances we selected for each structures. And then followed by the composition matrix. It shows all the detailed composition for each category member, like the constituent or impurity, and also the concentrations of each constituent or impurity. And then important is the data matrix. Here is the final data matrix with all the data. And also the data matrix can be exported separately as Excel files for better documentation. So generally, we documented all the information we used in the assessment, as well as the procedures, like how we modify this data, how we make the data gaps, how we fill the data gaps. So everything is documented. So if we submit this report, or if we further look at this report, we can easily find all the information required. So I think it will support the justification documentation requirement required by ECHA. So in contrast to the traditional procedure, as I already showed for the practical example, the AMBIT will help us to generate a more consistent and a high quality and also transparent report by involving less effort and spending less time. Basically, it helps us so for the category and the reader course approach, so makes things easier. I think maybe it's something helpful here. So thank you for your attention. Any questions here? Yes, please.
You said everything is documented in the report. Does it mean that every studies or result that you suppressed and so you didn't use in your assessment is still documented that you suppressed it?
Yes. For example, the experiment in this in this part to create Excel files with all the data. So Excel file will be exported, and in this Excel file, not only the data we used, but also the other data, all the information will be documented.
And in the report, is there a way to enter a justification why you didn't consider this data?
Yes, here I think there's this section followed by 6 or 7. So in this section, the detailed justification can be imported. And also here, if you, for example, if you delete a data, so you have to give justifications why you delete this data. And here, if you fill the data gap, you can also you should also justify why you choose the reader cross or other approach to fill the data.
But I meant, is there a kind of window that is opening saying that where you can put the justification so you can find it directly in the report?
Yes, here you can import the information here, and it will also document it in the report.
Thank you.
Can you explain how structural similarity is calculated? Because I know that there's various differences of opinion. And the second question is, we now know that we can choose chemicals for read across not just based on structural similarity, but also on mode of action, for example. Is that incorporated into AMBIT in any way?
Yeah, first question, the similarity I think is based on the Tanimoto index, if I understand correctly. From the index, we plan to include other methods to define the similarity, but currently it's a Tanimoto index. The next step would be incorporate. We have also considered to incorporate other methods like structure alerts and something so on, and mode of action. So it's in our plan, but it's further for the further versions. And the next question is, if you know the mode of action, you can freely add the chemicals as you wish by search the chemical and manually select it as a category member. So it's very flexible here. But the mode of action is supported by external tools.
I would like to add to this that you could use like TOX3 because you have for some of the mode of action you could get information from there. So this is one of the way to go through this. Indeed, as I showed in my talk, there are a lot of functionality behind AMBIT which are not yet exposed in this read across workflow. For structural alerts, you could use the structure menu when they already defined structural alert, and you can search not only by similarity but by structural alerts. But of course, we're still working to integrate all these functionalities in the best possible way. So this is a very nice question.
Yeah. So for example, if you know the metabolite of this target chemical, you can directly search the metabolites here and to add it in the list, in the category.